a short historical remark on how in music theory some theory has been developed, yet aside from the algebraic combinatorics of words. The authors Norman Carey and David Clampett published in 1996 the following proposal. So here we have a lattice representing the monoid of all products of 4/3 and 3/2, so fifth and fourth in any combinations. And you can order these numbers. You can order them, just increasing order. And what Norman Carey and David Clampett did, they isolated a rectangle which is bounded by neighboring powers. So this, which would be 3/2 to the third power and 4/3 to the fourth power, they are neighboring. You see they are connected. There are no other numbers in between. So in this rectangle, they isolated the diagonal as a zigzag in order to create the hexachord, but not as an ascending step pattern, but as a folding by fourth and fifth. Please remember this for a second, and we go to something else. I switch off again the light. This is the so-called Rayleigh tree, called after George Rayleigh, where you create a binary tree of all positive rational numbers. You do so if you have a ratio like 3/2. You would either add the numerator to the denominator, or you would add the denominator to the numerator, and you get two new nodes, so 3/5 or 5/2. And I present this, I like this didactical method as rectangles, which are so to say completely filled with squares, and the configuration of squares is a memory, a record of the pathway down the tree. Now you would always either append a square to below or to the right side. And so you already know, okay, I went down and then to the left and then down again. Down to the right, sorry, and down again. Okay. So this tree has a dual where you have another method to construct the nodes, and this is known as continued fractions. So here, this is the Stern-Brookot tree. So here, every rational number has two successors which are finer, so to say, finer ratios which approximate some number more precisely. So that means you see those rectangles become, the shape becomes more and more refined on the way, while here the shapes of the rectangles would jump from thin ones to fat ones and vice versa. Okay, so now let's put diagonals into these rectangles, and as you will see, these are central words. We do zigzags, so we always start here in the middle of the uppermost square, and yeah, I skipped the details, but the result is those diagonals are precisely the central words, and you have them on both sides of the tree. And now let's look again at this pattern, EAB, which is different from the one I showed you before, the AABAA. But this is precisely the zigzag in the publication by Norman Carey and David Clampett. So now we have two patterns, and you see two representations of the hexachord. This is an ascending step pattern, whole step, half step, whole step, full step. Whereas here we have fourth down, fifth up, fourth down, fifth up, fourth down, fourth down again. And these correspond to two dual nodes on the Rayleigh or the Stern-Brookot tree respectively. On the one hand, let me first explain how this relates to the solmization. The system of notes, so all the repertoire of notes which you can draw on the musical score, spans a lattice, a commutative lattice, so C over 2, the second power, because it is generated, for example, by fourth and fifth. Or you can think of the major steps, E, and the minor step, E to F. Now both, you can have the one basis or the other. And in the solmization, we use both patterns. We find both patterns. And there was a confusion between two slides. Now I show you first the duality. We have AAB, AA, which is the step pattern, and here we have BAB, AB, which is the folding pattern. If we trace them down the tree, we go left, left, right, and here we go right, left, left. The patterns on the tree are dual to each other. This is the central tree, which relates to the stem-broker tree, and if we look in the other one, it's dual, which in that case relates to the Raynaud tree. We have right, right, left, and now the two patterns switch their position. I go back again. So here you have the zigzag of the folding pattern here and the step interval pattern here, and in this slide they are switched. And the two successors of the Guidonian hexachord look like this, and I will show you the musical meanings of this. If you start from the note C, then this hexachord is called the hexachordum naturale, so the natural hexachord. If you append now a hexachord to the perfect fourth, you get a hexachord which includes a B flat. This is called molle or mollis, and then you have the other one where you have to be natural. This one is appended to the fifth. So these are precisely the two continuations on the tree, and this is the way how the hexachord solmization works. So we have all the notes on this lattice, and again, C, D, E, F, G, A, and so on. Here you have octaves, and in the medieval times it was bounded by the B flat on the one side and B natural on the other side. Later in the centuries we got more and more notes. And potentially the modern notation system is precisely modeled by this lattice. So we have one hexachord, which is here the durum. It starts on G, on a low G. I switch the line, as you can see. And there you have the names now, wood, fa, sol, re, la, mi. But then, if you want to go higher, you have now ambiguities. You have other note names for the same note, so other syllables. So now you have a natural hexachord, and then you get a mollis, and then you get another durum. And that could continue an octave higher. So this is so that you have overlapping hexachords, and this is how this mnemotechnique worked. There is a drawing in Guido Arezzo's Micrologus. It looks like this. And as David Klempit in a recent talk in New Orleans, a special session at the American Mathematical Society meeting, pointed out that this is precisely the folding of the concatenation of the hexachord naturale with durum. So if you look at this long central word and fold it, then it seems to say that Guido de Arezzo was aware about central words. Okay.